You should remember from the first week of class, we talked about this idea of statistical problem solving. We said that the statistical problem solving process has three steps. The first step is to collect your data. The second step is to analyze the data. And the third step is to draw conclusions from the data. We started our study of statistical problem solving in the middle of the process. We talked about analyzing data by using exploratory data analysis in chapters 1 through 4. What we're going to look at now in chapter 5 is learning how to collect data. It is important to be able to know how to collect data well so that we can draw good conclusions from the data in chapters 6 through 14. Generally speaking, there are two types of methods that we can use to collect data. The first one we'll talk about is what's called an observational study. An observational study observes individuals and measures variables of interest but does not attempt to influence the response. An example of an observational study might be presidential election polling, where news organizations try to predict who people are going to vote for president by asking individuals who they're going to vote for and trying to draw conclusions about how the entire population might vote. The second way in which we're going to talk about collecting data is through an experiment. An experiment deliberately imposes some treatment on individuals in order to observe their responses. An example of an experiment might include pharmaceutical drug testing. Maybe you work for a pharmaceutical drug company in which you develop this drug that you think is going to cure the common cold. So what you do is you take two groups of individuals. Half of them you give the drug to, and the other half you don't. Maybe give them some type of placebo. So you're imposing a condition on the individuals. In the end, you're observing whether or not that the common cold is cured. We'll be looking at types of observational studies in section 5.1, and we'll be looking at experiment designs in section 5.2. So section 5.1 is going to be all about designing samples. In statistics, we say that the population that we're trying to draw information about is the entire group of individuals that we want the information about. The entire group of individuals that we want information about is called the population. When we try to contact every member of that population as part of our method of collecting data, we call that a census. So, a census attempts to contact every individual in the entire population. Frequently, we don't have the time or the money or the resources to try to contact every member of that population. So instead of taking a look at the entire population, we just take a look at a small part of that population that we call a sample. A sample is a part of the population that we actually examine in order to gather information. So what we're doing when we're going through the process of sampling is we're studying a part in order to gather information about the whole. If we want our conclusions that are based on our sample to be valid for an entire population, we must have a sound design for selecting our sample. The design of a sample refers to the method that's used to choose the sample from the population. Poor sample designs can provide misleading conclusions. So let's take a moment and talk about some poor sample designs. If you take a look at example 5.2 in your textbook, example 5.2 is what we call an example of a voluntary response sample. A voluntary response sample consists of people who choose themselves by responding to a general appeal. That is, a voluntary response sample is one in which people choose themselves to be part of that sample. Voluntary response samples are poor samples because they're what we call biased. We say that a study is biased, or the design of a study is biased, if it systematically favors certain outcomes. Voluntary response samples are biased because people that have strong opinions, especially negative ones, are more likely to respond. When you read example 5.2, they talk about how these call and opinion polls are biased. These voluntary response samples are biased because the people who tend to call in are those that have those strong opinions, and they're not necessarily representative of the entire population that we're trying to draw information about. Another poor sample design is what's known as convenience sampling. In convenience sampling, the subjects choose. No, let me try that again. In convenience sampling, we choose the individuals that might be easiest to reach. A good example of convenience sampling can be found in example 5.3 in your textbook, this concept of interviewing at the mall. Both of these sampling designs are poor choices because they are biased, because they involve personal choice in selecting our sample. Personal choice leads to bias. Statisticians get around personal choice by using impersonal chance. When we use chance to select our sample, we're giving all the individuals an equal chance to be chosen. The simplest example that I can give of a design that involves chance is by putting all your individuals' names in a hat and picking out those names at random. This is the idea behind what's called a simple random sample. So the definition that we're going to use for a simple random sample, which we'll abbreviate as an SRS, is that a simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. So not only does each individual have to have an equally likely chance of being selected, every combination of these n individuals that you want in your sample, every combination of those n individuals from your entire population has to have an equally likely chance of being selected. For example, if you had a class of 30 students and you knew that you wanted a sample of size 6, if you were to make a list of every single possible combination of 6 students from your class size of 30, you will have a certain number of combinations. Each of those combinations of 6 individuals must also have an equally likely chance of being selected. There are other sampling designs that give each individual an equally likely chance of being selected, but not each sample the equally likely chance of being selected. We'll look at those a little bit later. As I said, the classic example of choosing an SRS is by picking names out of a hat. Now, practically speaking, we might not always be able to put the entire population's names in a hat and pick our names out at random. So frequently what we like to do is maybe use computer software or what's called a table of random digits. This is a piece of a random number table that you'll find in the back of your book. They call it Table B for the random number table. A table of random digits has 2 important properties. First, each entry in the table has to have an equally likely chance of being any of the 10 digits from 0 through 9. Now you can see that the first column here, these are not your random digits. Those are just line numbers to make it easy to read the table. I might tell you to start at line 101 or line 107 or any other line for that matter. The rest of the digits are what are going to be our random digits. And you can see that each of these single digits are the digits 0 through 9. As a matter of fact, when you look at the table, not only is it true that each individual digit has an equally likely chance of being the digits 0 through 9, but if you take a look at any 2 digits in a row, for example, 19 or 92 or 95 or, for that matter, 39, any of 2 digits in a row have an equally likely chance of being the digits 00 through 99. Any 3 digits in a row, 192, 575, any 3 digits in a row have an equally likely chance of being the digits 000 through 999. And secondly, the entries in our table, each of these digits are all independent of one another. The value of any one digit on the table does not depend on the value of any other digit in our table. So, how can we use a table of random digits to help us choose a simple random sample? We're going to choose our simple random sample in 2 steps. The first step is to label each individual in our population with a number. Maybe 1 through whatever, or maybe you want to start at 0. Either way, you have to assign a numerical label to every individual in that population. And then we will choose labels at random using our random digit table. Let's take a look at example 5.4 on page 276 in our textbook. This example walks us through the process of choosing an SRS. And what you can see here is that we have 30 business clients, and what we've done is we've numbered them 1 through 30. Notice that for the digits or the labels 1 through 9, we're labeling them with a 2-digit number, 01 through 09. That's because the largest digit that we have, the largest label that we have of 30 is a 2-digit number. So we want to be consistent and give 2-digit labels to all members of our population. Then what we do is we go to our random number table and we look for 2-digit groupings. Now, sometimes I'll tell you where to start on a specific table. Other times it doesn't really matter where you start. But let's take a look at what they've done in this example. And they've started at line 130. And you can see that what they've done is they've broken line 30 up into 2-digit groups. 69, 05, 16, 48. Now, even though you see a gap in the first 5 digits versus the second 5 digits, that gap is only there to make the table easier to read. It doesn't mean that we have to stop at 1. It just makes it easier to read than squishing all the digits all together. So you can see what they've done here is they've taken those 2-digit groupings, and the first 2 digits, 69, don't apply to any of ours, so we're going to ignore them. The next 2 digits, 05, well, that's the Bailey Trucking. The digits 16 correspond to JL Records, and so on and so forth. You have to know how to use the random digit table to select your random digits, but that's only one way in which we're going to select our digits randomly. Other ways that you're going to find we're going to use are by using the random number generator on our graphing calculators, and that statistical Fathom package also has a way to generate random digits to help us select samples.